All right, we're here to do a video walkthrough of learning target number 10, data modeling, practice quiz number 2. Two things you're going to need for this quiz: a ruler and a calculator. Make sure you got them both. All right, so first step, sketch line of best fit, describe the association, answer questions. So let's start here. The graph above shows the amount of money an ice cream truck made in a day compared with the temperature that day. Ice cream sales on the y-axis. The x is temperature in degrees Celsius. Describe the association. So, positive or negative? Well, as I can see, as x gets bigger, the dots are going up, the data points are going up, the y value is getting bigger, so I would say this is positive. Strong or weak? Well, the dots are pretty closely together, the data set's pretty closely gathered together. If we were to draw that line of best fit, they would be pretty clumped together. So I'm going to say strong. Is it linear or nonlinear? Generally, the data points form a line, so I'm going to say it is linear. Are there any outliers? No, I don't see any points that lie outside the general range of the data. Nothing strikes me as a point that's way outside. Now let's sketch our line of best fit. So if I go down, I'm trying to draw a line through kind of the middle of the data. Your line's going to look a little different than mine, but that's okay. So I'm going to draw a line right around there. That looks pretty decent. All right, make sure you draw it all the way across. Try to draw it straight. So now let's use our line of best fit to answer the following questions. About how much will the sales be if the temperature hits 26 degrees Celsius? So 26 degrees Celsius is right there. So I'm going to track up to see what my line says, and it says right there. So that's where on my line, I have a point that is 26 degrees Celsius. Now I want to know, how much will the sales be? Well, in that case, I got to go see what's the y value at that point. Well, it's a little bit above this line. So I might say it's around approximately $610. All right, it's a little bit above that line, that 600 line right there. Next, about what temperature is it if there were $500 in sales? Well, I see $500 in sales right there. I go track over and see what my line says. It says it's right around here. Go down, looks like it's about 22 degrees Celsius. Okay. Again, I just went across to see where that my line had a y value of 500 and then found the x value. That is level 1. Let's move on to level 2. For level 2, you are given data points. You are given a line of best fit. Now let's find the equation. Specifically, it goes through these 2 points, 85, 86, and 75, 78. Our first step is to find the slope. The slope is delta y over delta x, which in this case, we look at our change in y. So our y values are 86 and 78. So 86 minus 78. And then we're going to do that over delta x. Now in this case, delta x, I'm going to do it in this blue color here, are the x values. If I used 86 first, I have to use 85 first for my delta x. 85 minus 75. Now 86 minus 78 is negative 8. 85 minus 7, positive 8, apologies, over 10. So that means my slope is 8 over 10, which is the same as 0.8. Okay. Now, as I think about my equation is going to be, let's see, y equals my slope, 0.8, x plus b. Now you're going to see why I'm using all these crazy colors here in a second. All right. I know my slope, again, is 0.8 because that came from right there. Now, I want to solve for this b value. I need to see what is b. So to do that, I need to substitute an x and a y value. I could choose either one, 75, 78, or 85, 86. I'm going to pick 75, 78. So I substitute 75 for x, and I substitute 78 for y. And let's see what this equals. What is 78? 0.8 times 75 is 60 plus b. That's a b right there. Subtract 60. And you get 18 equals b. So what's my final equation? Y equals my slope, 0.8x plus my y-intercept of 18. So last question on level 2. Describe what the slope means. What's my slope here? My slope is 0.8 over 1. So delta y over delta x. So this means delta x is 1. So as what changes by 1? So as midterm score, that's my x value, right? That's my x value. So as my midterm score increases by 1%, we expect our y value, delta y, our final exam score to increase by 0.8%. Essentially, we're just explaining that as delta x changes by 1, because it's 1 right there, instead of delta x, what does x represent? Use your scatter plot. Use the data. Midterm score. As delta x changes by 1, midterm score increases by 1%. We expect the final exam score, delta y, we expect delta y to change. Well, in this case, delta y is final exam by however much it's changing, 0.8%. All right, that is level 2. Let's go on to 3. Using the line of best fit and finding residuals. So here, tadpole age versus tail length. What is the predicted tail length for a 5-day-old tadpole? Well, 5 days and 5 days old. Well, we got to think about, is that X or Y? Well, I see here that age is X. So this tells me that X equals 5. Okay. So as I look at my equation here, I'm going to use this equation right there. That's my line of best fit. So I'm just going to rewrite that equation up here. Y equals negative 1.3x plus 17.5. Now, I wrote here x equals 5. It's a 5-day-old. 5 days is my age. So I'm going to take that value and I'm going to substitute it for x. So negative 1.3 plus 17.5. What value am I going to put in for x? 5. What does this equal? So y equals negative 6.5 plus 17.5. And that's going to equal 11. So we would predict the tail length to be 11 millimeters. Well, in this case, what is the residual? Now, residual, what does that mean? It's an actual value minus predicted. What's the difference? You can see the residual on the graph right there. This is the residual, the distance between the line and the data point. So in this case, the actual, what's the coordinates of this point? 5, 11, 12, 13. So the actual value is at 5, 13. Now, what do I care about? I care about the y value. So the actual value is 13. My predicted value is this right here. This is my predicted value. So what is my residual? 2 millimeters. Okay. It's in the same units as the y values. Our data point is 2 units, 2 millimeters above our predicted value. It's higher than it. That makes sense. All right, last one, causation versus correlation. We have to decide what's going on here. As ice cream sales increase, the rate of shark attacks increases sharply. Circle what is happening here and explain your choice. Well, is there causation? Does eating ice cream make you more likely to be attacked by a shark? Sure, sharks do enjoy a good burst of Rocky Road every now and then, maybe mint chocolate chip, but I'm not sure they can really tell. Do shark attacks drive up ice cream sales? The more people that get eaten by sharks, the more people want to buy ice cream. I just don't see that holding. So I wonder if there's something happening here. What might be going on? What might connect these two? Well, ice cream sales increase when? When it's hot. What else happens when it's hot? People go to the beach. Where do shark attacks happen? At the beach. If there's more people at the beach, it makes sense there might be more shark attacks. So we could say a hidden or lurking variable that might cause this association might be temperature. As it gets hotter, it causes both these things. Or we could even say maybe it's related to season. Like if it's summer, these are both more likely to happen. So let's explain this. Again, what are we talking about? So an explanation might be when it is hot outside or the temperature rises, people are more likely to eat ice cream and go to the beach. There you go. Go to the beach. If more people are at the beach, there are likely to be more shark attacks because there are just more people there. So that's how temperature or the season could cause both an increase in the number of ice cream sales and an increase in the rate of shark attacks. Hope this has been helpful. Good luck with LT10.